All right, good morning. We'll go ahead and get started. So what are we doing today? Go ahead and pull that up here. So we're going to learn how to divide. And you learned how to divide in fourth grade, probably, fifth grade, I'm going to guess, somewhere in there, possibly third. So when you were in grade school, you started off with things that were pretty easy, like what's 48 divided by 6? And you would say 8. And then you eventually got to numbers that was like, what's 49 divided by 6? And you would say, well, 6 doesn't go into 49, and I know this says 48. And then you do what's called long division, where you multiply with this and you subtract it off. And I have two girls, and I know they don't do long division quite the same like they used to when I was in school. So hopefully this rings a bell. So we're going to use long division, but instead of just numbers, instead of just numerical values, look at that. We're going to be taking a polynomial divided by another polynomial. Okay, it looks hard. It really isn't. You just have to follow the same pattern. But let's go ahead and start off with a little bit of review from, grade school. So we call this number, we call that the divisor. What are you dividing by? And then the thing you're dividing into, we call that the dividend. And I hope I spelled that correctly. And then what you get as a result from taking the dividend divided by the divisor, we call that a quotient. So if I say find the quotient of 48 and 6, you would just take 48 divided by 6. That's what quotient means. Here's something that's interesting. Just like in this problem, 6 times 8 is 48. And so there is no remainder. So if there's two options, either you have a remainder or you don't. So if the remainder is 0, something is true. And if the remainder is not 0, something is true. Okay? And what we're going to be talking about is the dividend. So here's what's interesting. So if the divisor, so if I take this divided by this, and I get a whole number with no remainder, then that means the quotient and the divisor are factors of the dividend. That means that 6 times 8 is 48. Now, if the remainder is not 0, then neither the quotient or the divisor are factors. Now, this pattern holds true for polynomial division. Let's do a very, very, very easy polynomial division. So this is my dividend, my divisor. What's the quotient? So I'm going to say x times what is 2x squared. Well, x times what is 2x squared would be 2x. So then I take 2x times x, that's 2x squared. I subtract it off, and I get 0. So then we're done. There's nothing else to do. So since the remainder is 0, that means that x and 2x are factors of 2x squared. In other words, x times 2x is 2x squared. Okay, so you might see some problems where they'll say, is this a factor or not? And to know if something is a factor, you must have a remainder of 0. So then you would do all the division. If you get 0, you say, yeah, it is a factor. If you don't get 0, then you say, no, it's not a factor. So let's get to polynomial long division, and I have tons of examples. I will go through as many as I possibly can. There's like 15 of them. There's no way I could go through all 15. Now the first rule when you do polynomial long division is all terms, and we call these terms, it must be written, and I guess you could call it sequential order, but you should have your highest degree first. So you should have your 4, and then your 3, and then your 2, and then your 1, and then your constant. Same thing with the divisor. These should not be out of order. Okay, so all terms must be put in, I'm going to call that standard form order. I guess you could say sequential. Now, if you're missing a term, like let's say this said 2x to the 4th, and then it said minus 2x squared, you have to put a 0 in here to hold the place. So you have to put in a 0 if it's missing a term. And I'll show you an example of that. Okay, so here's an example. I want you to take this dividend divided by this divisor. So what is the quotient? What is the quotient of this? And one thing I find very tricky is sometimes I think this looks like a plus sign. And if you look closely, it's not a plus sign, it's the division sign. But here's what we'll do. First, everything's fine. We're just going to go ahead and start. You're going to start with the first term. And you're going to ask yourself, 2x times what is 2x to the 4th? 2x times what is 2x to the 4th? Well, I already have the 2, so all I really need is x cubed. Okay, so I'm going to put x cubed. And then I take x cubed times 2x, and then x cubed times 1. I'm going to put those down here. I'm going to subtract off those, and then bring down the next term. And then I'm going to continue that same pattern. So 2x times 2x, x cubed times 2x is 2x to the 4th. And then you take x cubed times your 1. That's plus x cubed. So you would take x cubed times any number of terms here, put them down here. Okay, you're going to take that away. Here's where it gets tricky for kids. And some teachers, they just say change all the signs. So let's say change that to -2, change that to negative x cubed. So you negate everything. I'm not really that kind of teacher, but this first term should cancel. 2x to the 4th minus 2x to the 4th, the first term should always cancel. If it doesn't cancel, then you have part of your quotient incorrect. So let's go through. 2x to the 4th minus 2x to the 4th is 0. And then x cubed, and now this negative is going to change this positive to a negative. So it's really x cubed minus positive x cubed, which is also 0. So both of these cancel. Okay. So those cancel, and then I could just bring down my next term. And usually they don't both usually cancel. That's doesn't happen very often. All right, next we're going to see 2x. So this 2x again times what is -2x squared. Well, 2, I would need a -1 to get to -2. And then x times what's x squared would just be x. And then I'm going to take -1x times 2x, -1x times 1. And because 2 terms canceled, I need to bring down my next term. We're going to go -1x times 2x, and that is -2x squared. -1x times 1 is -1x. I'm going to take that away. See what I get left. So this negative is going to change that to a plus. So this is -2 minus -2, which is -2 plus 2. So these go away. And then this is 9 minus -1, which is the same thing as 9 plus 1. So this becomes 10x. Bring down my next term. Now, I am going to ask myself, 2x times what is 10x? That would be 5. And now I'm going to take 5 times 2x, 5 times 1, put it underneath. 5 times 2x is 10x. 5 times 1 is 5. I take it away. 10 minus 10, 0. 5 minus 5, 0. So all this is 0. Okay. So here's what I have. If you take this dividend divided by this divisor, we found the quotient. We get left x cubed minus 1x plus 5. Now, if there was a remainder, you always put plus. You put the remainder over the divisor as a fraction. Okay, so that's really all there is to this. Questions you might see, especially on, say, the district assessment, they might say, is 2x plus 1 a factor of 2x to the 4th plus x cubed minus 2x squared plus 9x plus 5. You may be going, I don't know, is it? Well, we said at the top of the page that if you get a remainder of 0, then both the dividend and, both the divisor and the quotient are factors. So because we got a remainder of 0, we would say, yes, 2x plus 1 is a factor. So you would say, yes. And again, you only have to answer that if they ask. So you may see problems on your practice where they say, is this a factor of this? You divide, you get a remainder of 0. You say, yes. You divide, get a remainder of anything but 0. You say, no. All right, here's another one. They put it out in order for us. I like to make sure. So the highest degree is 3. So I should have a 3, a 2, a 1, a constant. I do. X minus 1 is fine. So let's go ahead and start. So I'm going to ask first, x times what is 2x cubed? That'd be 2x squared. I then take 2x squared times x. That's 2x cubed. I take 2x squared times -1. That's -2x squared. I take it away. These should always cancel. 2 minus 2 is 0. Good. And then we have 1 minus -2. That'd be 1 plus 2. So it'd be 3. So it'd be 3x squared. I bring down my next term. I then say, okay, x times what is 3x squared? Well, x, and why am I doing x? It's because it's this term. X times what is 3x squared? That's 3x. I then take 3x times x. 3x squared should be the same. It is. I take 3x times -1. That's -3x. I take both those away. Notice it's the same pattern every time. Take it away. 3 minus 3 is 0. That's good. That's gone. Here we get -4 minus -3. Minus negative is the same thing as plus. This is really -4 plus 3. That's -1x. Bring down my 2. And then I ask myself, x times what is -1x? So x times what is -1x? That'd be -1. I take -1 times x. I take -1 times 1. Just double checking my work real fast here. Hold on. Yeah, everything looks fine. And then I take that away. -1 minus -1 is 0, because that's a +1. 2 minus +1 would be 1, so that's 1. Now this one had a remainder, so I would say that x minus 1 is not a factor of this. I would also say that this is not a factor of this. But I need to write down my answer, so I'm going to write down 2x squared plus 3x minus 1. All I did was copy this part down here. And because there's a remainder, I put the remainder over the divisor. All right. This is how you do polynomial long division. I want to make sure we do some different examples, but we'll do this one real fast. I may not color code it just to show you that it's really not as long as you might think. So you start, you go 4, 3, 2, 1 constant. That's good. Here it's 2, 1 constant. That's good. So you start off with your first term. X squared times what is x to the 4th? So you go x squared times what is x to the 4th? That's x squared. And then you take x squared times this, this, and this, put it down here. X squared times x squared is x to the 4th. X squared times 2x is 2x cubed. X squared times -6, -6x squared. I take it away. Those cancel. 3 minus 2 is 1. -5 minus -6, that'd be +6. -5 plus 6 is 1. And then I bring down my next term. And then I ask myself, x squared times what is x cubed? 1x cubed, same thing. I would need one more x, so I do plus x. I then take x times x squared, x times 2x, x times -6, I put that there. So x times x squared is x cubed. X times 2x is 2x squared. X times -6 is -6x. I take that away. 1 minus 1 is 0. That's good. That's gone. It's supposed to be gone. 1 minus 2 is -1. -8 minus -6 is -8 plus 6. That'd be -2. Then you bring down your last term. Then you say x squared times what is -1x squared? That'd be -1. Notice how these are also going down in number. You take -1 times all three of those, you put it underneath. So -1 times x squared is -1x squared. -1 times 2x is -2x. -1 times -6 is +6. Take it away. Negative minus negative, that makes a +1. So those go away. -2 minus -2 is the same thing as -2 plus 2. So those go away. And then 6 minus +6 is just 6 minus 6. That also goes away. So we're left with 0. So my answer is x squared plus x minus 1. No, and the remainder is 0. So since the remainder is 0, this and this are factors. Okay, so I'll even take this a step further. What that means is, if I ask you to factor this, if I said factor this, which I don't even know how to factor it by hand, to be honest, that is equal to x squared plus 2x minus 6 times x squared plus x minus 1. So if you were to factor this, it factors in this, and then you can factor this and keep going from there. Okay. All right, so every example I have shared so far had no missing terms. I need to show you at least one example where we have a missing term. And I might just set some of these up for you. So if I were to divide 4, I would take this, I'd put it in, and notice it goes 3, 2, 1 constant, so I don't need any placeholders. X squared plus 5 is missing the x term. One thing that helps me is if it's to the third power, you should have 4 terms. 1, 2, 3, 4. If it's to the second power, you should have 3 terms. It's always one more than the exponent. And so this only has 2 terms. And so what you're going to need to do is put in a place value. So you go x squared, and then you're going to use 0. So putting that 0 in there is very, very important. So I might just set some of these up and then solve one for you. Looking at the clock, we don't have that much time. But then you would divide that. Here, I'm taking dividend divided by the divisor. Notice that's x squared. So if it's x squared, I need 3 terms. I only have 2. It's because I'm missing the x term. So I have to, you absolutely have to. You have to put x squared plus 0x plus 9. You have to put that 0 in there. And now x plus 3, that's x to the 1, so you need 2 terms. We're good. Okay. Number 6, there's nothing special about that. We'll skip that one. Nothing special. Number 8, again, this is our dividend to the 4th power, so I need 5 places. I have 5 terms, or 5 places. I have 1, 2, 3. I need 5. I'm missing something. I am missing the x cubed, and I am missing the x. I must put in a 0. So I'm going to put 12x to the 4th. And then because I'm missing the 3, I'm going to put plus 0x to the 3. And then I'm going to put in the square minus 5x squared. And then I'm missing the x, so I put plus 0x. And then we have our minus 3. And I'm going to divide that by x minus 2. And then I would say x times what is 12x to the 4th, subtract it out, so on and so on. But really, I want to make sure that we know how to put place values in there. Here, second power, I have 3 of them. First power, I have 2 of them. We're good. Here, fourth power, I should have 5. 1, 2, 3, 4, 5. Second power, I should have 3. I'm good. So those are just like what I've been showing you. Here, x squared, I should have 3 terms. I'm missing the 0x. So when you divide, you need to put the 0 in there. All right, I think I'm going to just try to finish this problem real fast, and then that'll be it. Okay. And then just for sake of time, I'm not going to use the color coding. I know it helps, but I only have 5 minutes. So I say x times what? It's 12x to the 4th. And remember, it was 4th power. We had to put in a 0 for the x to the 3rd, a 0 in for the x. So x times what is 12x to the 4th? That'd be 12x cubed. I then multiply 12x cubed times x, 12x cubed times -2. 12 times -2 is -24. Take it away. Those go away. Some people even cross them off. 0 minus -24 is plus 24. X times what? Oh, bring down the next term. X times what's 24x cubed? That'd be 24x squared. So x times what is 24x cubed? 24x squared. Take that times this, that times that, put it underneath. 24x squared times x, 24x cubed. 24x squared times -2 is minus 48x squared. Take it away. Those go away. 24 minus 24. -5 minus -48 would be -5 plus 48, which is 43. Bring down your next term. I almost put 1. That would have messed it up. X times what is 43x squared? That'd be 43x. 43x times x is 43x squared. 43 times -2 is -86x. Take that away. You get -86x. Bring down your -3. And I'm going to cross off that 20 so we don't think it's part of the problem. X times what's -86x? -86. -86 times x is -86x. -86 times 2. Oh, too early in the morning. Want -172. Take that away. That'd be plus 172 would be 169. So that's my remainder. So I would say 12x cubed plus 24x squared plus 43x minus 86 plus, and then you put your remainder over your divisor. All right, I know that was a lot. So long division really isn't hard. It looks hard. All it is you multiplying, subtracting, multiplying, subtracting, multiplying, subtracting. That's all it is. Okay. I will show you an easier way next class period, which I'm still not even sure when that is. I'm pretty sure, looking at the calendar, that the next class period is Tuesday. But other than that, I ran out of time. If you need more help or you want more examples, you can log into the office hours. Nice seeing you both. Have a good day. Or seeing all three of you. Bye-bye.